Okay, so it's 12:01. We'll go ahead and get the ball rolling. Good afternoon, everybody. Thank you so much for joining. My name is Sarah Grasty. I'm the outreach coordinator for COMIT. And today is the day of our July webinar. I hope to see everyone again as we continue our monthly webinar series, always on the fourth, at least for now, on the fourth Wednesday of every month from noon to 1 Eastern. So our webinar series focuses on a large range of topics related to COMIT's research goals, such as technological advances related to seafloor mapping, operational applications of hydrography, safe navigation, and many other topics. So I'm going to go ahead and drop the links to our webpage, our Twitter account, as well as how to sign up for our newsletter so you can stay up to date on everything. I'll drop that in the chat just as soon as I am done talking your ears off. But I'm going to hand over the mic to our center's director, Dr. Stephen Morawski, so he can introduce our distinguished speaker for today, Ms. Colleen Peters. And after Colleen's presentation, we'll have a good amount of time for questions. And so to participate, please either utilize the chat feature or raise your hand, and we'll make sure to call on people in order. And if you're a student, Colleen has graciously agreed to take time after her talk to meet with you all more one-on-one from 1 to 1:30. So definitely try to take advantage of that. Just one last note, if you just came in, you're welcome to leave your video on for the duration of the talk, but please keep yourself muted until the Q&A portion of the webinar. So with that, I'll hand it over to Steve.
Yep, thanks, Sarah. I really appreciate that. So as she mentioned, our guest today is Colleen Peters. She's the Bathymetry Manager at Saildrone Incorporated. Her academic background, she got her bachelor's degree at the Maine Maritime Academy in Castine, and a master's degree, two master's degrees at the University of Rhode Island, one in oceanography and the other one in business administration, which in this day and age is an important combination to have. She's currently the bathymetry manager at Saildrone. She spends her time doing quite a few different things for them in terms of assisting in the integration of sonar systems and data management tools aboard the Surveyor, as well as setting up bathymetry data pipelines for many of their company's mapping operations. The title of her talk today is Mapping the Unmapped Remotely. So since we're having a remote webinar, take it away, Colleen.
Excellent. Let's go ahead and share my screen. Can everybody see that? Can you guys?
You're all good.
Okay, great. Thank you guys so much for the wonderful introduction. I'm really excited to be here. This is my first public engagement since I started working for Saildrone a couple of months ago as the Bathymetry Data Manager. So I'm going to talk to you today about what it's been like to start new frontier, really, of mapping the seafloor remotely. So first, I'd like to just begin by talking a little bit about what is Saildrone, in case you are not familiar. Saildrone is the name of the company, but it's also the name of the product. A saildrone is a uncrewed vehicle that is propelled by wind and solar and travel the ocean to collect in situ scientific data. And the one that's pictured here is an Explorer drone, and they have a variety of different sensor payloads that can be carried on this platform. And they travel all around conducting various scientific transects or crossing oceans, reaching very remote parts of the globe. One of the most recent accomplishments was the circumnavigation of Antarctica. So they have a variety of different sensors available. We have somewhat of a standard suite with meteorological and oceanographic sensors. Of course, there's navigation sensors. We need to know where they are in order to direct them where they need to be going on their missions. And a lot of that data can be found in our data portal. So that's available for the public and scientific community to check out. We also have cameras on board to monitor the drone itself as well as the environment around the drone. And then there's a couple of different sonar options. And so each of these drones can be
Oh, Colleen, I think you got muted.
Oh, can you hear me now?
Yes, you're all good.
Okay. So let me reshare my screen. How are we now? Good now?
Yep,
Yeah.
all set.
Excellent, thank you. So this is Saildrone headquarters. This is located in Alameda, California, which is on San Francisco Bay. And this is where Saildrones are designed, manufactured, so built from scratch from the production team. Then all of the cables and sensors are all assembled and installed on the drones. They can be deployed right behind the headquarters here in the lagoon on San Francisco Bay so that we can test all of the drones and all of the sensor packages on board before deploying for a mission. And when operating in the Pacific, for example, we can sail right from our home base here. But if we want to operate in a different area, like in the Atlantic, for example, the Explorer drones can be packed up and shipped to a more suitable location, like somewhere on the East Coast, and then deployed from there to really maximize the operational mission time. So lots of magic happens here. We develop a lot of the software that is used to run the drones, to navigate during the course of the mission, as well as to log and transmit all of the scientific data that becomes available on the mission portal, which is our online interface that scientific participants can use to keep in touch with where the drones are and what kind of data is being received by those sensors. So lots of great folks here. All members of the team contribute to the success of all of our missions. So over the years, Saildrone was founded in 2012. Over the years, we worked with a lot of different partners, private, academic, government, in an effort to learn as much as we can about the ocean and share that with the world. So a couple of sort of top examples of how Saildrones are used. Again, the drones are customizable to your mission, so we can put a variety of different sensor packages and sonars on each platform. But a couple of top ways that they're used are for measuring very fragile environments such as the Arctic. The Explorer drone doesn't have an engine, so it's completely wind and solar powered. So it makes a very environmentally friendly platform. And that's quite important in some of these much more fragile ecosystems. Another example would be when surveying marine mammals or fisheries acoustics. As it doesn't have an engine, it is an extremely quiet platform as well. And so when you're measuring these kinds of targets or trying to get close to marine mammals, sound in the water can sometimes have an adverse effect to your data. So being able to collect that data with a very quiet platform is incredibly helpful. Something else that's been coming up in the last several years has been maritime domain awareness. So Saildrones have begun to be used for security purposes to supplement the resources provided by our Coast Guard and other law enforcement agencies that patrol the coast. So this can include traffic monitoring, illegal fishing monitoring, port security, just getting more eyes on the water where it might be otherwise difficult to get more boats and people on the water, particularly in some more remote parts of our coastline. I think that one of the biggest contributions that Saildrone has made to the scientific community has been with the ability to collect observations for weather patterns and contribute to weather forecasting and climate modeling, because a lot of these drones travel to remote areas where there are very few observations or very few ships working in those areas. And so they've been able to collect an absolutely tremendous amount of data all over the globe. But today what I want to talk to you most about is, of course, bathymetry. That is the newest capability of Saildrone and something that is very much up and coming in the autonomous and uncrewed vehicle world. So you guys heard from Dr. Larry Mayer about 2 months ago now about mapping, seafloor mapping, why we map, how we map, what it all means, and why it's important. And what I'd like to do is just sort of pick up where he left off and continue on forward, how we take this forward. So we learned very recently that 20% of the ocean is mapped. There's a global project that he talked about as well called the Seabed 2030 project. And this project is geared towards mapping the whole world ocean by 2030. But I would also like to just add a little bit extra piece of information here, because it's not really just about mapping the whole ocean. It's about mapping it and making that data publicly available. This is the real sort of key to the puzzle, because mapping is really the foundation for a whole host of seafloor oceanographic research and exploration. And much like you wouldn't go on a road trip without looking at a map, you want to know how far something is, what's around it, where you're going to stay for the night, where you want to go to dinner, what activities you want to do. You're going to do the very same thing when planning an expedition. You want to know where you're going and how much time you have to survey and to really target the areas that are of most interest for your research. So making the data publicly available is really the key to making that work for the entire scientific community, and also to allow the public to further engage in the ocean and learn more about it so that we can do more to protect it. So we have this goal of mapping the seafloor by 2030, and it would take every known research vessel 10 years to do this, working every single day with mapping. And there's a number of different challenges here. The first challenge is that not every oceanographic research vessel has mapping capability. They might also have the hardware, the systems, but they might not have the personnel to support them. Several ships do not have mapping staff internally. They will bring participating scientists on board to conduct that mapping surveys. And so it can be very challenging actually just to staff all of these vessels and get them out mapping every single day. Research vessel time is incredibly expensive. It can be somewhat cost prohibitive for certain activities. And the endurance of a research vessel is quite limited. And some folks might think that that's based on fuel capacity, but typically the endurance will be much more limited by provisions. So the food, the fresh food that a ship can carry, and that could be 30 days, 40 days, 60 days. And that can also lead to a lot of logistical complications. So a lot of the ships that are operating now that have this mapping capability and have this staff, these resources, this infrastructure, they don't necessarily do mapping cruises only. The NOAA hydrographic survey vessels certainly do, because that's their specific task. But they can't even keep up with all the work that they have to do. There's a number of other commercial companies that assist NOAA with the task of mapping our harbors and channels and rivers and coastal environment. And so even if you have all of the hardware, all of the infrastructure, and all of the people, it's still pretty uncommon for oceanographic vessels to do mapping all the time. So there may be several expeditions a year that are dedicated to mapping to really knock out a wide area that is going to be further used for additional exploration. More commonly, vessels will do some mapping and other activities like exploring with sensor packages or underwater vehicles. And so that adds to the complex nature of really what we do. Because as I mentioned, mapping is the foundation for a lot of these activities. We use these maps to figure out where to go and where to further study. But we can't just stop everything else that's going on to use all these vessels to map. We need all of those other tools, all of those other sensor packages. We need time to test new methods and engineering for new equipment, new tools, in order to keep moving forward. Because mapping is really, as much as I love mapping, it really is just the first layer. So in order to protect an area, we need to not just map it, we also need to go and characterize it. And that happens with bringing vehicles down to the bottom to capture images and video of the environment, to take core samples and sediment samples and rock samples and biological samples, chemical samples. All of these different components work together to really characterize the area in which we can then take forward to hopefully protect the area. So what does this all really mean? What I'm getting at here is that we have a ton of vessels and institutes that do an enormous amount of really great work, and they need to keep doing that. So how do we go about mapping the rest of this 80% of the ocean by 2030? We simply have to think about approaching this in a different way with a different tool. And this is where Saildrone comes in. So, as I mentioned before, we have the Explorer drone, which is the smallest of the fleet. We have about 100 of these hulls available, and they will be used for a whole host of different activities. These are used really all over the world. Next, we have started production on our mid-class drone, which is known as the Voyager, and this will have our shallow water multi-beam and be focused on a lot of the coastal areas that have yet to be mapped. If you look at the Florida shelf, for example, a large portion of that is not yet mapped, and that's because it's very shallow. So line spacing has to be pretty tight, and it could be really time consuming. That's going to be very difficult and very expensive to do with a survey vessel. So this would be a really great particular survey for an uncrewed vessel. So then we have the Explorer, which is 7 meters, the Voyager is 10 meters, and then we have the Surveyor, which is the pride and joy of the moment of the fleet, and that comes in at 22 meters. And the Surveyor is going to be focused on deeper environments, as it has the EM304 multi-beam, which can map down to 7,000 meters. So this will help cover a lot of the deeper offshore, hard to get to, very time consuming mapping that all of those gaps that we saw in the image earlier. So this is what I'm going to focus on for today, because this is where I spend most of my time at the moment, is working on Surveyor, getting all of the bathymetry systems dialed in as best as possible, working out any technical issues, because every time you install a new system on a new platform, even if it's a ship, it's a new ship, it moves differently than any other ship, and things are plugged in different places than any other ship. It's the same exact process. You have to just systematically go through all of the systems and make sure that everything is neat and tidy, working in working order, and so that you can ensure that you're going to collect the best quality data possible. So that's a lot of what I've been working on, as well as the protocols for conducting the survey. So planning and execution, managing all of the data on board to make the transfer process very easy. So when we get the data off the vehicle, we can get it to our customers quickly and in good order, with all of the supporting metadata as well. So we have a lot of the same systems that you will find on the Explorer drones, the navigation systems, the meteorological sensors. It also has solar power. It's also propelled by wind, but Surveyor is a little bit different because it also has a diesel engine. And the engine is used to charge the batteries to supplement the solar power, because the payload draw for the deep water sonar systems is pretty significant. So we need just a little bit extra boost there. But we can also use it for propulsion. And while we try to focus most of our time surveying on sailing, because it's environmentally lower impact, it also provides us with a longer endurance. Using the engine for propulsion can help us get in and out of port effectively, can help us avoid obstacles such as traffic if needed, or weather storms, or if we have a very light wind condition and need to just keep the survey moving. So the fuel consumption is still quite small in compared to a traditional research vessel, that burns tens of thousands of gallons of diesel per day. We burn a couple of gallons depending on how much we actually use the motor for propulsion. So on the underside of the vehicle, we have the gondola, which houses all of the sonar systems. This is very similar to design to a number of other research vessels. And so this allows us to really mitigate bubble sweep down as the vehicle is pitching in sea conditions, same as same as the larger ships. And it allows us to collect very clean data. So shortly after I arrived, we conducted a small survey off the coast of California, right off of San Francisco Bay, in order to really exercise the systems and our survey execution. And we mapped an area that's about 1,000 square miles of unmapped seafloor and uncovered 2 new features. So one of them, the one on the bottom, was indicated by the UKHO satellite altimetry, and then the one on the top was not. So this is just a really great example of why we map, because pretty much every time we go out there and map somewhere that has not yet been mapped, we are very, very likely to uncover new features that we didn't know had existed. So this was a really great exercise to get the feel for the vehicle and how it moves and how well we can collect data in different depths and different sea conditions. And one really sort of interesting twist to collecting data with a sailing vessel versus a traditional research vessel is that I don't get to just plan lines how I want them. I have to take into account the wind direction so that we can maximize the vessel's maneuverability by trying to sail on the best point of sail, which is like a beam reach for this particular vehicle. So it adds just a little bit extra challenge, but to me, that's the really fascinating part. So shortly after we did that, we started our inaugural voyage, which I'm sure most of you or many of you have heard about from the news. And this was to sail from Alameda, California to Honolulu, Hawaii. And along the way, we were able to successfully map a lot of the existing gaps in coverage. And since I live in Rhode Island, the bathymetry team is quite spread out. I'm in Rhode Island. My counterparts are in Louisiana, Nevada, and Texas. I like to measure everything by the size of the state of Rhode Island, so we mapped 22,000 square kilometers, which is approximately 5 times the state of Rhode Island. And we did that in about 28 days. So I've done this transit many times on several ships, and it was a little bit slower than the ships would be. Our speeds range from about 3 knots to 5 knots, depending on the sailing conditions. The sailing angle was not quite ideal, so we did end up motoring for part of that expedition, but we were able to keep mapping the whole way and keep all of the systems running and fill in as many gaps as we were reasonably able to. And so then we came into Hawaii. So these are just a couple of really, really quick examples of some of the features that we uncovered and what the data looks like. And we have a connection to the vehicle to be able to conduct the survey, so operating the sonar systems and also doing some light data processing. I didn't spend the sort of normal amount of time that I would on a ship killing dots, but we did enough. There's some great tools now that really help us filter the data a little bit more easily, a few less button clicks than just the traditional dot killing. So that's been exceptionally helpful in this particular use case. So we're able to do some light duty processing of the data on board the vehicle through remote connections and then transmit that data back to shore. So not the complete raw file, but the processed products. So we could keep our partners that were working with us during this particular mission, keep them up to date on what we have covered, as we go along in the whole voyage. So as I mentioned earlier, the research vessels, depending on the size and the capability and the range, and there's all these other factors, they are run on the effect of tens of thousands of dollars per day. And so that could be really cost prohibitive to do some of these larger surveys, either surveys in very remote locations where it's very difficult to get to, or some of the shallow water work that just takes a lot of time. And so being able to operate an uncrewed vessel that's operated remotely is on the order of a couple $1,000s per day. And so this really presents a much more attractive solution to be able to fill those kinds of gaps than a traditional research vessel. I think that a really great opportunity would be to combine forces between Saildrone and research vessels, and having Saildrone do a lot of the mapping, the research vessels focusing on some of the other tools that you really need a ship to deploy. And so there's lots of options here to make this a really cost-effective solution for a variety of different purposes. In particular, we're able to keep operating 24/7, just like you would a ship, but our endurance is not based on people. Our endurance is based on the vehicle and the data. So when we want to retrieve the data, or if we need to do any vehicle maintenance or update any systems, those are really our limitations. And so those are really driven by the missions themselves. And so this would be a really great tool to be able to reach some of the much more difficult regions of the oceans where it can be very challenging logistically to get ships to. So, of course, we have the reduced carbon footprint as well. So this is a very low environmental impact. Even with Saildrone Surveyor having a diesel engine, the fuel consumption is completely insignificant compared to big ships. So in addition, there are additional opportunities for us to really expand the workforce. On ships, there could be some challenges for people having physical or medical limitations to sailing on board. And a lot of that really is related to their personal safety while on board in adverse conditions. And so now that we can sort of do this remotely, which is how the bathymetry team operates, we can bring in a whole host of people that might not have had this opportunity previously. And so this really not just opens up to people with physical limitations, but also who might not have had these STEM opportunities, or been able to have the tools to go to sea, or the travel or financial capability to meet a ship in a foreign port. And so having people spread across the country is also really helpful, because then it makes it really easy to line up the watch schedule to monitor all of the systems. And so we can bring in people from not just all over the country, but all over the world. And so that just really, I think, makes our industry even stronger. One of the things that I thought was a really unique and wonderful accomplishment was last year during the pandemic. Of course, it was very difficult for everybody. It was very different sets of challenges and some different extremes for the maritime industry. On one hand, you had commercial ships that had to keep going because we all needed our groceries and toilet paper. And a lot of the crew of those ships were not allowed off the vessel on their regular rotations because of various regulations. And so that was very challenging in one way, whereas for the research fleet, a lot of the ships were laid up for the year, tied to the dock, and nobody was able to go out to sea and continue to collect data for the research projects that had been planned. And so that's a very different kind of difficult challenge. And so with Saildrone, we have vehicles that can be deployed with just a few people, physically deployed with a few people, because everybody's able to continue to work remotely to access all of the various resources. It made this a much more flexible platform to be able to be deployed in a really adverse conditions. So it allowed Saildrone to keep operating and keep deploying vehicles to continue to collect data. And so one particular example was that the NOAA ship Oscar Dyson, which is my old ship, was not able to make it to Alaska for their annual pollock survey. And this is the largest U.S. fishery, and this data has been collected for decades, and it's used to inform the policymakers. And as the ship was not able to go to Alaska, the one of the Explorer drones were outfitted with the sonar systems required to go and collect that data in lieu of the ship. And that turned out to be a rather successful partnership. And so it's not just a flexible platform for, environmental impacts and, low carbon footprints and, it's a very flexible to different types of missions, and then also in different logistic challenge conditions. So with that, if you have any interest in discussing any future potential projects, please let us know. Be happy to have those conversations with you. We're still working through dialing in some of the systems and getting everything working as tip-top as we possibly can. And we look forward to conducting some future missions with you. So I would be happy to take some questions.
Well, thanks a lot, Colleen. Great presentation. Appreciate it. We're open for questions. People can either put their questions in the chat, or they can raise their hands with the raise hand function that you all have on Teams. So do we have any questions for Colleen? So, there we go. I think we have one. Who is that?
Like David is first.
David.
Yes, wonderful talk. I really enjoyed listening to it. And I wanted to ask you a question that many people in the audience also might be sailors. What do you do when the wind shifts and is on the nose? How do you keep sailing? Because I know once you make a change in course, you're going to really create a swath that overlaps part of your survey and create a gap in another direction.
Yeah, well, that's where on the Surveyor having the engine could really help. So we can just turn on the engine and keep going. Of course, being on the nose, wind being on the nose is not ideal really in general. So I think it also sort of depends on the level of the wind conditions and sea conditions. There might be a point at which we need to just hold off and wait for the wind and waves to come down a bit. Once we get above 25 knots, that gets a little bit unfavorable. So we would probably just alter our line plan to try to, move to another priority area to try to cover in a different direction and then resume as soon as the weather was more cooperative.
And I take it you have a staff full-time monitoring the situation?
Yep, we have a pilot that will be on duty to monitor the navigation of the vessel, so making sure that the correct route is in place, that all of the vehicle monitoring systems are working as they should. We have software support for that as well. And then we have a separate group of watchstanders for the bathymetry systems. So we have 24-hour support right now to make sure that we are getting the quality data, covering all of the, getting the overlap that we want, covering the whole survey area, collecting sound velocity, all of the normal things, just from Rhode Island.
Thank you.
Catherine, do you want to ask your question?
Yeah, sure. Mine was kind of similar to Dr. Nar's, where you were saying in the Gulf of Mexico it'd be really useful to use these because it's shallow water bathymetry, so you have to do a lot of lines. But because we have hurricanes a lot, would you suggest that there's like a certain season that you only use these sail drones in an area that's prone to like crazy weather?
Yeah, I mean, I think we would just, operate the same way that all of the other vessels do. We would want to certainly take that into account and plan the survey accordingly. We're not gonna, just like you wouldn't send people on a boat to go do that. We're not gonna do that because it wouldn't be very successful. If the wind conditions are really that high, then we're not going to be doing a whole lot of mapping anyway. So we would definitely plan according to those kinds of conditions. And just to note, we actually have a couple of drones that were just launched recently off the East Coast to specifically and purposefully go into hurricanes to help take measurements at the sea surface. So, but those drones are
cool.
designed very specifically for that task.
That's awesome. Thank you.
Dr. Fraser, would you like to ask your question?
Sure. Hey, I really enjoyed the presentation, Colleen. So my question relates to similar to David's in a way. Because of the way that the data are collected, you have a lot of overlap, right? And so that provides you probably with a unique opportunity to kind of provide some type of an accuracy assessment of the data that are collected. And just wondering, how accurate it might be and how you use that information, the overlap really.
So are you asking in terms of what, I guess, what specifically do you want to know?
So for example, if you take, if you're trying to map a feature or something, right, and you get a single pass, and you get a kind of a good representation of what that feature might look like, but then you have multiple passes, right, and allows you to kind of refine your view of the world. I guess I'm trying to figure out, is there a lot of discrepancy in those multiple passes, or are they line up kind of lockstep?
No, I'm finding that from the data that we've collected so far, they line up really well. And this is because we spend a lot of time to calibrate the system. So conducting patch tests and then collecting sound velocity. So we do have a sound velocity profiler on the aft end of the vehicle that we can deploy and collect in situ profiles. So those two things really help us, plus having the correct amount of overlap for the whatever particular survey we're doing gives us the sounding density to give high confidence in the accuracy of the soundings. Yeah.
Yeah, perfect. Thanks.
Sarah?
Yeah, so first, thank you so much for, I really appreciated your comments on sort of the broader impacts of a company and approach like Saildrone has with the work-life balance and, being able to connect people from all over the world. I think that's fantastic. But my question is more of a material science one. So you mentioned that there is, the capability to be out 365 days a year with no maintenance. So as far as fouling goes, do you know what kind of research went into whatever is either painted or the materials used on the Saildrones to make them capable of doing that?
I'm not familiar enough, so I do not want to answer that question, but I can find the answer for you. That's just not my expertise on the production side, so I just don't want to say the wrong information.
Okay, yeah, no, and I guess a follow-up question is, how long did it take to get to this stage for Saildrone, from like kind of initiation of the concept of it to this point where you're basically at like, frequent operational level?
Yeah, so I don't know the full history in great detail, but our CEO had broken the land speed record, and so for land sailing, and so he took the wing that he designed for that purpose, and that has been further adapted for what is now known as Saildrone, and so that I believe was around 2010, and the company was founded in 2012. And so the Explorer drones have been operating for quite a long time now. And then Surveyor has just come online in the last year. And so that's been in design for about probably a year and a half or so. So now that we have the vehicle and we've done all of this testing and we understand how we want to make improvements, then we can work towards building future drones, the fleet of Surveyors and the fleet of Voyagers with this new information, and we can make this much more efficient process as we continue to build and adapt the fleet.
So, Colleen, I have 3 questions if you can indulge me. I'm just busy scratching all these questions out. So my first one is, and it kind of follows up on what Tom Fraser said, and that is, when you showed that plot of the 1,100 square kilometer area that you surveyed off the West Coast. That was a very nice picture, and there weren't any holidays in it. You know, there weren't any places where, you know, you know, for whatever reason, you didn't negotiate, you know, to actually have coverage on it, right? So that probably means a fair amount of overlap. But you know, is that because you were able to follow up on the holidays with the motor, or is it just the way you're able to sail in that particular configuration?
Yeah, it was largely because we were able to sail on a very favorable point of sail. So we had the wind on the beam and did the survey lines from approximately east to west in that particular condition. And so we did leave one holiday, but we were able to turn around and go back and fill it in. So really the same way that we would do any survey on any other ship.
Gotcha. Yeah.
The-
No, I've seen other papers, you know, using Saildrone that, you know, were perhaps less favorable in the wind conditions, and you know, they're good, but there's also, you know, some gaps there as well. So, you know, that's obviously a consideration in looking at the trade-offs between platforms. So my second one is, you know, since you have a business management degree, I'll quiz you on this a little bit. You mentioned that, you know, perhaps the daily ship costs were like a couple of $1,000s a day, right? So does that include your operator who's in Nevada or wherever that person is, or is that a sail away cost kind of thing, or is that pretty much the ship operations?
Yeah, it's my understanding, and I would have to just follow up with you on this, but it's my understanding that the operational costs are the complete operational costs.
Gotcha.
Yeah.
So my third question is perhaps a more altruistic question, and that is, you know, so Saildrone and other private corporations are collecting this bathymetry data, and as you pointed out in your first, you know, introduction, that, you know, we had 20% of the world's oceans mapped. So what, you know, given the fact that you're a private company, what's the contribution of the data that you collect for all these people that hire you into the larger data set that, you know, will be the national archive or the global archive of all this?
Yeah, absolutely. So as with really any other operation, the ability to share the data will vary based on our funding, right? So if we're funded by NOAA, then the data will become publicly available. If we're funded by the military, we may not be able to make that publicly available. So there are some caveats, or if an educational institution is collecting that data to publish, maybe there's a moratorium and then it becomes publicly available. But something that I would like to do personally to mitigate that is something I'm working on currently, is to be able to, at the very least, if we're not able to share the data, or if we're not able to share the data in a certain amount of time, I at least want to share where we've collected data. I want to share polygons on a publicly available map, or that can be integrated into other tools, so that people know where we've mapped. Because as we continue to try to fill the gaps, we're all kind of doing it at the same time, and not everybody talks to everybody else to know what each other are doing. Some of us have the pleasure of knowing a lot of our colleagues and having some of those hallway conversations, but we've really got to get a lot better at sharing that. So if we're not able to share the data, I'd like to at least most immediately share where we've collected data, and then at least people will know to reach out to us if they don't find it otherwise in the archive.
Yeah, the biggest sin of all has got to be to map the same place twice because you didn't know somebody else did it. Right? Even if it's private, you can go over and beg it from them.
Exactly. But I think that the problem is that most of the time we just don't even know that somebody's already done it.
Right on. And, you know, honestly, if JEVCO could do one thing, or Nippon, to actually just, you know, coordinate this would be great.
Yeah.
So we have a question from Alex and then from Matt.
Just before, I just wanted to add that our transit data will be shared. So that's in UNH's hands to process, and then they will be making that available through Seabed 2030.
Outstanding.
Yeah.
Alex? You may be talking, but you're muted.
Alex, it looks like you're unmuted, but maybe your microphone is not set up correctly. If you want to put it in the chat, you can do it that way.
Speaking of the chat, there is a question from Derek Sowers about, can you download raw data or do refueling at sea, or do you always have to refuel and download data in port?
So I'm working on the data part now. Thanks, Derek. I am able to make some of the products available, as I mentioned, processing during the course of the mission, and I'm currently investigating the raw data. But at this moment in time, we need to collect that when the vehicle is in port alongside. We're investigating the option to be able to refuel at sea. That may or may not be for Surveyor. It may be more for Voyager, which would be operating close to shore. So that's in development.
Gotcha. Matt, do you want to have your question as Alex sorts his technology out?
Yeah, sure. I got a quick one to fill the dead air. On the SVPs on the Voyager and the Surveyor, are those an in-house system that you've designed, or something off the shelf that you've then integrated into the vehicle?
Yeah, it's an off-the-shelf sensor that we've integrated into the vehicle, and we're working on improvements to those systems with the manufacturers.
Okay, cool. So like winch and everything, that's all from a third party?
Yep.
Gotcha. Okay, thanks.
Yeah.
Sarah, you get another bite of the apple there?
I do. I have another question, but first, Alex, do you want to try your microphone again?
Working now?
Yes, you're a little quiet, but it is working.
Okay, cool. Yeah, I really enjoyed your talk. And you mentioned that there's kind of several lines in the Saildrone product lineup. Mm-hmm. And I noticed that both the mid and the large size could be used for multi-beam. Florida is a bit unique in that we have like a very wide continental shelf, so it's relatively shallow, so it was in the range of what the mid-size could do, but I was wondering which one would be a better tool given that it's shallow, but it's also a very large area. Would the diesel engine then come in handy, or would the mid one be sufficient?
Yeah, we're focusing on preparing the Voyager for exactly that kind of operation. It's going to be smaller and more nimble, and then it will have the shallow water multi-beam, which is really focused on those depth ranges. So the continental shelf areas that need to be mapped are really between sort of 20 meters and 200 meters. So that really is going to be a much better fit, where the Surveyor would be much more effective at mapping deeper areas further offshore.
Thank you.
You're welcome.
So just to follow up on Alex's note, please share with your colleagues. We'd be really interested in partnering on some proof of concept on that. You know, we have the location and the unique shelf here, right? So Mark Luther has a question. It's a good one. What are the rules of road, of the road, the coal regs rules of the road with respect to your sailing craft and other vessels that are in the vicinity?
Yeah, absolutely. That's why we have a variety of navigation systems on board. Just the same kind of things that you would find on many other ocean-going vessels. So we have radar, we have AIS. So we're able to detect other vessels in the area. We're also able to monitor with marine traffic, and then they will targets that are identified will appear on our navigation system, and so we're able to track the vehicle relative to them, very similar to the way you would on a ship in person. Gotcha.
No, I can imagine, with a lot of commercial ships, even though sailing boats have the right of way. It is what it is, and a lot of these vessels, they don't deviate from their tracks, period, right? So.
Yeah, and this is why we have 24-hour monitoring. So we have one person focused on the safe navigation of the vehicle, and then a second person on the data.
Gotcha. Okay.
Yeah.
So we have a question from Jing Chen. Do you want to ask your question?
Hi, very nice talk. I'm really enjoying it. And I have a question. Since I'm working on Tampa Bay, and then the average depth of Tampa Bay is about 3 to 4 meters. So how How shallow can this Saildrone go?
I think that currently we're looking at maybe not more shallow than about 10 meters, and that's, I think, pretty common for a lot of survey vessels, and especially as this is going to be operated remotely. It could get a little bit dicey working it quite that shallow, encountering hazards to navigation. So I think might work our way towards that. We're going to start in the deep and work our way shallow.
Do you think there is a limit in the future? So how shallow it can go to?
Yeah, I would say probably not less than 10 meters.
Okay.
Yeah, I think that's pretty much the entire state of Florida territorial zone in the Gulf of Mexico out to 9 miles, right?
Yeah, I mean, the other factor is that it becomes extremely inefficient to map with a surface vehicle of any sort at that depth. So it really would be a better use to do LiDAR from the air, for example, to cover that crossover.
Okay.
Yeah, it's this is the real challenge of all of the let's map the world's oceans is the 0 to 40.
Yep.
That's once you cross into Hawaii, your beam spread is substantial, right? It's kilometers, right? So you can pile up some mileage there. I think we're just going to mow with a very small plow. Sarah, your question?
Yeah, so I was curious, obviously a company like Saildrone is going to need people with hydrography skills, but can you talk a little bit about the other types of expertise that as Saildrone's workforce grows that they'll be looking for?
Yeah, we're going through a pretty enormous expansion at the moment. There's a number of jobs posted on our website for a variety of different positions throughout the whole business. And I think that some of the opportunities are going to be in the mission management sector. So as we have more and more drones out in the field, particularly during survey, we're going to need more hands on deck to monitor those. And I think that a lot of those folks can come from the marine transportation world. So we have at least one other academy grad that I'm aware of on the team right now. And so a lot of those folks are sailors who have, done a lot of ocean sailing and are really familiar with all of the navigational concepts. And so I think that that's going to be pretty important because also, it's the Explorer, the way the Explorer drones are operated, they'll have a mission set and they'll just sort of go on their way. If they're collecting sensor data, if they're 10 meters off, the air temperature is not going to make a huge, impact. But if we're 10 meters off on a shallow water survey, that will have an impact. And so we're going to need a lot more operators to be really focused on actually navigating and routing and rerouting the drone as we have, various challenges, avoiding traffic or having to fill in a holiday, things of that nature. So it's going to take a lot more active communication than sort of the normal operations.
Okay. Thank you.
Okay, last chance for questions for Colleen. I certainly have a lot of others, but I'll defer. So Catherine did say that she'd be interested in staying on for, if students want to chat with her for a while. But please join me in giving her a round of applause for her excellent presentation today. So much appreciated. And please give your colleagues at Saildrone our best.
I sure will.
Okay. Thank you all for joining. I would just like to end and say, as Sarah said before, this is one in a series of our monthly webinars sponsored by COMIT. Our next one is on August 25th, and it's Dr. Qasim Abdullah from Wolpert, which is not a competitor, but a partner, I guess, in the private sector world of ocean mapping. And so it'll be real interesting to listen to what the folks at Wolpert have to say. So with that, thank you all.
Thanks, everybody. If you're a student, stay behind. Take advantage of the opportunity.
Indeed.
Hi, Colleen. I'm a student. I actually am helping teach a camp right now, so I have to head out, but I might send you some emails with some questions.
No problem.
Okay, thanks. Have a good one.
Thank you again. I think that went really well and lots of good questions at the end. And yeah, and we're going to throw it up on the YouTube page. And I know Larry's got a lot of hits, so I'm sure yours will as well.
Yeah, everybody just wants to know what's going on. So, yeah.
Do we have any students? I see some students.
Yeah,
I know you're here.
I'm
Yes, there they are.
People.
Hi. That was great. Thank you.
Oh, you're welcome. Thanks for coming.
So
Matt, nice to meet you. Thank you for helping me.
Yeah, sure. I was glad to see you in your current incarnation. I actually had like lots of questions about, Ocean X and Ballard's outfit because wasn't the right venue, but yeah, like billionaire philanthropy oceanography. I have thoughts. We could do a whole webinar on that. But, yeah, I'm happy to see you ended up at Saildrone, and yeah, I'm hopeful we'll be able to continue to interface.
Yeah.
Yeah, great talk.
Thank you.
I was wondering if the use of autonomous vehicles has any effect on or any potential with calibrated backscatter, because a lot of the reason why you don't have calibrated backscatter is it's because it's a pain to take the ship completely out of the water and put in a tank. The bigger sail drones still seem pretty big, but much smaller and much lighter, I assume, than a ship.
Mhm.
Is it more feasible to calibrate it, or is it still very much difficult?
It's interesting because that's something that I'm starting to think about because just like having reviewed some of our backscatter data, I have questions for Kongsberg on how to go about doing that. The Surveyor is I think it was about 15 tons, so not going to be lifted up and put in a tank. It would have to be done out in the field. And that is something that some ships will do. And I think it depends on the ship, right? Just what your priorities are and dedicating the time to do that. And so that's something that I need to work out with Kongsberg, how best to approach that.
Yeah, I guess potentially then, because you guys aren't limited by time as much. Like they've talked about having natural areas to kind of pass over to do a calibration. So I guess you could do like kind of a standard pass somewhere.
Yeah, hopefully.
That's something we're looking at, maybe setting up one in our neck of the woods here, Alex. So there's I don't know if it was technically the first of its kind, but I think it's currently the most well-maintained or most frequently measured as the NOMAX line up in New Hampshire, right out UNH's backyard there. So I think, yeah, we'd like to explore that concept. I know there are like kind of a super double secret network of those patches all around the country that ships make use of. And to my knowledge, there's not one near Tampa Bay, and it seems like it would be good for our outfit to get one set up out there. But then the question becomes, who sets the standard, right? Who's the reference? And something like Saildrone, I think, has a big advantage there, and the platform is incredibly quiet when it needs to be, and that could be pretty close to ideal for setting up that kind of reference patch.
Other questions?
I have a career-related question. For some of us students and like maybe some recent graduates that would want to work for a company like Saildrone, do you have any advice or certain education levels that you're looking for? Anything like that?
Well, I feel like, so I worked on ships for pretty much my whole career. And then I left Falcor to go to graduate school and then found myself on a different ship, Ocean Explorer. And so it just seemed like I was not going to get away from that, so which is quite fine. But I feel like having arrived at Saildrone, that really was like the job that I was aiming for by going to graduate school. I kind of went on the blind and just was like, okay, I should just have some master's degrees or something on my resume. I think this is going to be something that could really boost me later. And I think it really did the trick. I didn't have any really specific job in mind, and I just kind of went and did it, and I learned a lot. And when I got back on the Ocean Explorer, I really kind of learned that mapping is really my home, where I want to be. And then when this position came available, I jumped on it. And I think having that graduate degree really, really elevated me compared to some of the other applicants. The other thing I think for me personally was just that I have very specific experience in setting up new ships, sonar systems, and so that's something that's particularly applicable to a place like Saildrone, where we're going to be doing that frequently. So I think that graduate degrees, as kind of silly as they may seem to some folks, it's not really the piece of paper. It's not really the grades that you get. It's the effort that you put in to strive for that further educational experience, and the time management and the dedication and all of those other sort of soft skills that go with it, not so much what the actual paper says.
I have a question about Saildrone real fast to bounce back to that. I do some of the acoustics for the college, and we have a lot of problems, or at least where I was last, with like bubbles and a lot of other like interactions with your acoustic return. Do you have those problems like consistently with Saildrone, or can you like plan for them and predict them for when you're going to turn your motor on versus when you're just using wind?
Yeah, so I think that we mitigate a lot of the bubble issues by having the gondola, and this has been really a proven concept on several ships like Falcor and Ocean Explorer. So this is really generally a better design than having a fairing like the Okeanos. So that allows those vessels to be able to operate with better data quality and higher sea state. And because we're a sailing vessel, we have a very different form factor in the water than a big tubby ship. So we're able to really cut the water much more effectively than a big ship. So I think that partially really reduces our bubble sweep down issue. Across the whole transit, though we were going the right direction, there's a right direction and a wrong direction. So going from California to Hawaii is a better wind direction. So as far as for vessel motion, so we didn't really see any issues in that regard on the way down. So I'll be curious on the way back what that looks like, because usually as you approach the California coast, it gets a lot more bouncy. But we will also not really be operating into the wind very often, just sort of as the concept of sailing. And so we will certainly have occasions where we need to in order to transit to our next working area, or if we're trying to do a cross line. I have my current survey, for example, we have the wind on the beam for our main survey lines, but then I got to do a cross line. Do I go upwind or downwind? Because neither one of those is ideal. But if we're trying to hit the survey perpendicular, then we kind of have to do that. Some of the other drones, like the Explorers, will have the WBT minis, which are like the miniature EK80. And those, I think, see a bit more bubble issues. I haven't really looked at that data very closely, but just from a couple of the pictures that I've seen, I think there's a lot more bubble interference in that. But that's also a different hull design. So that has more of a bulb like you would see on a traditional sailing vessel rather than the gondola.
Okay. So when you're doing these transits from California to Hawaii, assuming like you're using the Kongsberg models of EKs, are you able to go in there and change your bottom detection as you move off the shelf? So you're not like pinging down to 1,000 meters?
Yep.
Oh, that's awesome.
Yeah, we use like a remote desktop type of application, and so we go in and actively control all of the sonars no matter where we're operating.
Okay. Do you have like an interval that you change it at? Because I know a lot of times we just add like 20 meters to what we were detecting. So.
Yeah, I mean, we don't want to, we don't want to keep clicking buttons like, every 2 seconds like you would on a ship, right? That with the latency and the connection that we have, pretty frustrating pretty quickly. So we'll probably do that in somewhat larger intervals. We don't have a specific workflow for the EKD yet. We haven't done a lot of data collection with that yet. The multi-beam has been our focus of the moment. Yeah, I would probably do that in somewhat larger intervals. Yeah.
Thank you.
This is kind of related, and I guess kind of a practical / business question. Is that something when you're using, like, if a scientist is using Saildrone, is that something that Saildrone does, or does Saildrone like set up the scientist with the software to do that?
Not currently, anyway. Our sort of protocol is that Saildrone people or Saildrone contractors will be the ones interfacing with the systems on board.
Gotcha.
Rather than the scientists. Right now, the scientists can access the data from all of the sensor data from our mission portal. And we're working on developing a bathymetry dashboard that actually brings some of that sonar data back to shore so that they can interact with that more readily. So not having to wait for me to like transfer a file and give them a file, but see the live coverage. So I don't particularly anticipate having participating scientists pushing the buttons, but certainly directing, what settings are optimal for the type of data they're collecting, like particularly with EKD, or if people are prioritizing backscatter or things of that nature. We definitely take their input.
Yeah, and then is the hardware itself, is it buy or rent? Like, do you buy a Saildrone system, or do you like rent it for like X number of days?
Yeah, you would rent it. So if you get a grant to do a study of wherever, a survey or something, then you would be contracting with Saildrone to use the assets.
Okay, thanks.
Yep.
Alex, I'll just jump in and add Nancy Williams, faculty here, I think is at this point our only Saildrone customer at the college, but she has a pretty big NSF-funded grant with them to do some work around the Antarctic. And she mentioned this in the chat earlier, but I've had trouble accessing the chat reliably throughout this. But she did mention that she'd be happy to talk about, the nitty-gritty from the scientist perspective with any of us, including but not limited to COMIT folks. Hi, Tucker.
Cool, thanks. Be great.
Always makes an appearance.
Yeah, Nancy's a great asset in that respect, that we actually have an end user around these parts for these systems.
Colleen, I have another question about, so how the skills and knowledge you learned during your MBA, how has that played into, your role now and being a scientist and working where you have?
Yeah, I think that it gives me a lot of perspective on just how to further do things efficiently, and managing the resources and time and people and all that kind of stuff. I think in particular it's helpful working in a business environment, right? We're selling a product and we have to deliver on that product, and so I think that it's more applicable in that way than the philanthropic organizations, for example. I think that it allows me to have very different conversations with the rest of the team, in terms of how do we sell the product and what tools we need, what numbers they want to show, making sure that, what we're saying we can do is what we can actually do, and having the data and operation experience to support that. So, I don't like to make certain claims about the quality of the data or anything until I actually can evaluate it and present that in a meaningful way. So we're doing a survey right now off of the coast of Oahu before we start traveling back to California. And so we're mapping an area that my old ship, the Falcor, had mapped with a similar system. It's not the exact same system, but very similar. And so, we're going to use that as a tool to derive comparison between the platforms in order to give folks confidence in our data quality. So I think that's given me, my MBA has really just given me a lot of perspective.
It's important perspective for sure. Thank you. Anyone else have any more questions?
I have one really quick. So if you're doing all the software interface, are you relying mainly on like Python and Linux programming?
The software for controlling the vehicle and logging the time series data from like the MET sensors and all of that's handled by a completely different department. That's our software development team, and I think that they do use a lot of those tools. On my side, I'm using the commercial software that comes with the sonar systems for acquisition, and then we're also using some QPS tools for acquisition with Quincy, and then processing with Chimera, Fledermaus, and all the rest. So I don't have to really use much in the way of programming or scripting myself. That's mostly handled by the software development teams.
Okay.
Yeah.
Thank you.
Mm-hmm.
All right, last chance. So we're going to let Colleen go so she can go eat lunch, do what she needs to do.
I actually have to go check on the multi-beam. I'm getting
do that. Very important. So yeah, all right. We'll go ahead and wrap it up there, and then if you want to contact Colleen, I'm sure she'd be happy to answer more questions.
Yeah,
Thank you.
Thank you.
Asking great questions, and I wish you all the best.
You too.
Thanks
Thank
so
you.
much, Colleen. Bye.
Thank you. Bye.